Hello everyone, welcome back to my YouTube channel and my name is Lata. I'm studying my third semester BE in Sri Venkateshwara College of Engineering in the Department of CSE Data Science, and today's topic is evolution of digital IC technology and its naming pattern. This is the table of contents. First, introduction of ICs and definition of IC, design of IC and its type, features of digital IC, commonly used ICs, evolution of digital ICs and naming pattern, lastly conclusion. Let us see first introduction about ICs. A digital integrated circuit is an electronic device that collects several digital electronic components on a small semiconductor chip. Usually each integrated circuit is designed to perform particular function. Next, what are digital ICs? Before going to discuss what are digital IC, let us see basic methods of making circuit. The basic methods of making circuits was to select the components like diodes, transistor, resistors, and inductors and capacitors and connect them by soldering, but due to size and power consumption issues, it was necessary to develop a small size circuit with less power consumption, reliability and shockproof. After invention of the semiconductors and transistors, things were quite simplified to the particular extent. But the development of integrated circuits changed electronic technologies phases. And the integrated circuit is a fundamental concept of electronics that builds on other basic concepts. As I told you before, an integrated circuits are made up of several components such as LCR diodes and transistors. They are built on a small single block or a chip of a semiconductor known as an integrated circuit. The abbreviation IC stands for integrated circuit and in practice denotes any semiconductor based on chip comprising an integrated set of digital circuitry. Let us see the design of integrated circuit. A digital integrated circuit is created using certain logic methods and circuit layouts. The two categories of IC design are as follows. First, analog design, digital design and mixed design. Let us see one by one. First, digital design. The digital design approaches is used to create integrated circuits which are utilized as computer memories such as RAM and ROM and microprocessors. And next, analog design. When ICs are utilized as regulators, filters and oscillators, optimal power dissipation, gain and resistance are required. Lastly, mixed design. The analog and digital design ideas are used in mixed designs. The mixed ICs performs either analog to digital or digital to analog conversion. And this is a diagram of process for designing digital integrated circuits. Firstly, system specification will be done. After specification, architectural design will be conducted and next functional and logical design and circuit design will be conducted. Physical design and physical verification and sign off and fabrication will be conducted and packaging and testing. After completing all the process, chip will be ready. Let us see some features of integrated circuit. First, construction and packaging. ICs are built with the semiconducting components such as silicon. Because of the small size and delicate nature of IC, a series of tiny gold and aluminium wires are joined together and molded into a flat block of plastic or ceramic. Metal pins on the block's exterior link to cables inside the solid block stops the chip from overheating and keep it cool. This is the sum of features of integrated circuit. First, size of an IC. The size of the integrated chip varies between 1 square mm to more than 200 mm. Next, integration of an ICs. Because they combine various devices on one chip, integrated chips get their name. A microcontroller is an integrated circuit that combines a microprocessor, memory, and interface into a single unit. And let us see which are the ICs we commonly used. First, logic gate ICs. The combinational circuit generates logical output based on a variety of input signals. It may only have 2 or 3 inputs but only one output. And timer ICs. A timer ICs is produced with accurate timing cycles with a 100% or 50% duty cycle. Next, operational amplifiers. An operational amplifier is a high gain voltage amplifier with a differential input and single-ended output. Voltage regulators. A voltage regulator ICs provides a constant DC output irrespective of the change in DC input. And let us see evolution of digital ICs and its naming pattern. Evolution of digital IC technology has witnessed a continuous march towards smaller, more efficient designs. The naming pattern of IC technologies typically refer to the minimum feature size on the chip, reflecting the semiconductor manufacturing process. And TTL and ECL area. Early ICs used bipolar transistor, adding to families like TTL and ECL in the 1960s and 1970s. CMOS emergence. The adoption of CMOS technology brought about increased power efficiency with naming patterns denoting the manufacturing process. Example 500 nanometer and 350 nanometer. Next, shrinking nodes. Advancement led to smaller nodes, enhancing integration and performance. Nodes like 180 nanometer, 90 nanometer, and 45 nanometer marked significant milestones in the late 20th or early 21st centuries. Deep submicron era. Continued miniaturization led to the deep submicron introducing 32 nanometer, 22 nanometer and 14 nanometer technologies. Single digit nanometer nodes. Recent years have seen the development of 7 nanometer and 5 nanometer technologies, pushing the limits of miniaturization for improved performance, energy efficiency and transistor density. And this is the overall conclusion of this topic. The naming conventions provide a quick reference to the scale of the manufacturing process, with a smaller number indicating more advanced and compact technologies. This evolution has fueled the progression of digital ICs and enabling the creation of powerful and energy efficient devices. And thank you for watching.